Hey, I'm Jake, and we're going to go over how to use the Faro Arm scanner. So first of all, we're going to go over how to set it up, and then we'll go into the software part. So to begin, we put the laser line scanner on the Faro Arm. It's just a setup into the spot and screw it on. And once it's screwed on, you can go around to the back and there's a single power button to turn the arm on. Once the arm is assembled and turned on, you will go to the computer and open the software called Geomagic Design X. All right, to begin a scan on the software, in the top left, you click the live capture. And it'll bring up this interface. Now this interface wants you to take the arm and move it through every rotation about all the joints in the robot until this screen goes away. And then once that's completed, you can begin scanning. So to scan, on the laser scanner, there's a green button and a red button. To begin scanning, you click the green button, and while the blue line from the scanner is on your part and the red crosshairs is also on your part, you can begin scanning. Now notice there's a ring of colors around the laser head, and that indicates how far away you are from the part. Every scan you make, you want to make sure that that line is green or yellow, but the software won't pick up points if the ring is red. So I'll begin here by putting my laser scanner the proper distance away and then press the green button on the handle. And then I'll move the scanner across, and you can see that the part is being created in the software. And you can do this multiple times, scan across, just to make sure that you have all the points from your object. And once one face has been scanned, you can click the green button on the handle again, and it'll pause the scan. So to get another face, I will bring the arm in, and if the interface comes up that you need to rotate the robot, it needs to be in a better position. But to resume the scan, I will re-click the green button and scan another face. And that should pop up on the computer as well. And once you've captured that face, you can click the green button again to pause the scan. And then I'll continue around every face of my object while making sure the robot is in the correct position and get a capture of every face. And you can see in the software if you've missed somewhere in your scan that you might need to rescan. So I'll get the top surface now. And finally, the right side. So now that you've completed your scan, you can see what your object looks like on the screen. To view any side of your object, you can use the right mouse button to rotate. You can use the middle mouse wheel to zoom in and out. And you can double click or click both the right and left mouse buttons to pan across your object and move it in space. So once you've established that you've scanned all the sides of your object, you can now begin to analyze the point cloud. To do this, you would click the check mark on the live capture, and it would ask if you want to continue with the scan data or continue without editing. What I like to do is just click continue. Wait for it to load. And then at this point, you can save your point cloud data. So if you ever want to come back to this point cloud and do any other sort of editing later, or if you mess something up later, you can always have this raw point cloud. So what you would do is go up to File, and then Save As this point cloud data. Once you've done that, you go to Points, and then Mesh Buildup Wizard. Mesh Buildup Wizard allows you to create a mesh from your point cloud, which will ultimately allow you to export this object as an STL. So I'll click Mesh Buildup Wizard, and the first step is data preparation. It wants to take each individual scan from when I was scanning and pausing and create a larger scan file from all of that. So I will make sure down here that all of my scans are checked, and you can uncheck a scan if you don't like it. Make sure that the scanner type set to line laser with the CMM arm, and you'll click this next arrow. Step 2 is data editing. So this allows you to delete any of the point cloud points that you don't want to continue editing with. So for this, since my object is a simple wall, you can go up into this menu, which is kind of like a CAD software menu, where you can view certain angles or positions of your object. For this stage, in the data editing, you can left click and drag and select points that you don't want to save. And so you can see that it's highlighted in a light blue, a lot of points. You can either click delete on the keyboard or click the trash can on remove unwanted data, and it will show you every point that it's selected to delete. So I can click delete, and that will be removed. So sometimes it's helpful to, rather than have a lasso select, maybe you want to select points with a rectangle selection mode. So you can choose your selection mode also in the top menu. So I will delete these points from my point cloud, and I'll go around deleting from every side of the wall that I don't wish to keep. You don't have to remove every single point here that you don't want. Usually you can do that in a STL slicer if you're doing some sort of analysis later, like MATLAB. But here you just want to reduce the number of points in your total file to save time and get you a cleaner STL. So for me, this looks good. From here, you'll continue on to the next stage, which is best fit aligning. I've never used this best fit aligning tool, and I don't know what it does, so I just continue on to the next stage, which is data merging. So this is where you actually take your point cloud and turn it into a mesh. In the HD Mesh Construction tab, you can choose the high definition filter. So a higher definition filter will give you a higher fidelity mesh. You can also choose the level of noise reduction. Normally, I like to just keep the noise reduction in the middle and the high def filter at HD. You can also choose to extend boundaries to fill holes. So if there are any holes that you failed to capture, or if you cut off a part of your point cloud and created a hole, you can fill those holes with either a curved or a flat section. Since my general wall here has a lot of curvature and I want to capture the unique curvature on the sides, I will choose to fill with a curved selection. Now to apply this mesh, you just left click apply, and it should run through the mesh construction. And this can take a while. So now, once you have your mesh, you can see that all of your scan data turned into one object. You can keep applying a mesh, but that will reduce the fidelity of your data. So at this stage, we're done with the mesh creation and the mesh buildup wizard. There are no more steps, so we'll go to this check mark and click OK, apply all, and finish. At this stage, I recommend saving your mesh so you can come back to it later and do any sort of data alignment that you want to do. As for data alignment, the object created in space is based purely off of the location of the base of the Faro Arm scanner itself. So the origin of this part is not located anywhere on the actual object. So if you want to change the location in space or reestablish a new origin for any sort of data analysis you might want to do in a third-party software like Python or MATLAB, and you want to maintain a origin between multiple parts so they are imported in the same relative space, you can use the interactive alignment tool. But first, you need some sort of reference on the object to reference in the interactive alignment tool to change your position. So I'll go to Model, and here you want to create a series of planes, vectors, or points. So for me, I want my origin to be right here in the middle of my wall on this face. So what I'll do is create a plane. The method for my plane creation will be extract. And I want to best fit a plane to the points that I've extracted. So what I'll do is change my view to this side of my wall, move it to the center with the left and right click, and then make sure my selection tool is the rectangular selection mode. And then I can select points off of this face to best fit a plane to. I'll click OK, and you can see that I've created a new plane on that face. Additionally, I'll create a face off of the bottom of the part that will become a new orientation. I'll go to the plane selection tool. It automatically selected the plane I just made, so I will click that and then click this star, which deletes my selection, and now I can extract a new plane from the bottom of my object. So now I've got two planes which will establish my new top and my new right side of my object. And then, like I mentioned earlier, I want my origin to be right about here. So if I were doing multiple of these walls and I wanted them all to come into MATLAB in the same space so I could perform the same analysis automatically on them, then I'd want them all to have the same general origin. So for the point, you just click a point on your object with the pick multiple points method and click OK, and that'll create my point. You can also make sure that it's on this plane with the point tool. If I click this plane, you've kind of got to move it or move your cursor around so you can select the plane and then select a point on your object. Then it'll project that point onto the plane in that space on the object. But I like where my point is, so I will discard that point. All right, so now in alignment, I'll go to interactive alignment, and I'll make sure that my entire object, this scan data 000, and you can see there's a box around my entire object, so it's selected that. And I'll go to next, and these two panels here show you where your object is relative to space on the right, and then just where your object, or how your object looks on the left. So every transformation you do here will show where you're transforming it to in space over here. Now, since I want to use the origin, I need to be able to see the origin on the right side panel. So I'll go to Menu, View, Visibility, Show All. And now you can see that the origin has appeared. And what I want to do is an XYZ alignment. You can also do a 3-2-1, which requires a plane, a vector, and a position. But I want to do XYZ, which requires a position and then at least 2 planes. So for my position, on my moving target, I'll click the point that I created. And then for my target location, I'll click the origin. And then for my axis Y on my object, I'll click plane 1. Got to move around to select. Wait till it's highlighted. And then for my axis Y on my target, I'll pick the right side plane. For my Z-axis on my object, I'll pick this bottom plane that we created, plane 2. And for the Z-axis on the target, I'll click the top plane. Now, I want to view from a better angle where my object is in space. So you can see currently it's here, but by target location it's flipped in some directions. So to orient it correctly, I want it to look like this over here. So I'll click these flip. So now it's on the correct side of my new right side plane. And then I'll also flip the Z. And you can see that it's oriented this face perpendicular to the other faces in the correct position in space. So I will click OK. And now you can see that the origin is on my object at the point that I selected. Now the top plane is not exactly the exact bottom of my object, because the plane that I selected, the plane that I made, was not exactly flat, because I did not create this face with any sort of point cloud data. because this face was hidden when I scanned it. So if you're doing this, you can scan this, you can create a plane off of this face here, which you actually scanned, which would be flatter than the bottom that was created. It was filled in the mesh buildup wizard. But for our purposes, this is fine. So from here, you'd want to save your mesh, and then to export this as an STL, you go up here to this export, select your entity, and click OK. Now it should give you the option to export as a binary STL file and name your object. But if it doesn't say save as a binary STL, then there's probably a hole somewhere that was not filled in correctly during the mesh buildup process. Now the way to fix that would be to go into the healing wizard. The healing wizard will find all your non-manifolds, your folded polyfaces, your holes, small clusters that aren't connected to your object, and things like that. And generally with the standard settings, it'll get rid of a lot of that and fill holes. And then you'll be able to export as an STL. There's also the fill holes feature. If you know there's only holes, that'll allow you to fill holes that are of a certain size, and you can choose how to fill those holes. Now that you've completed the mesh buildup and the STL export, you can take that STL and import it into SolidWorks, add features to it there. You can import it into MATLAB, and you can even use it straight off of the computer onto a 3D printer to print your object. So thank you for watching the Faro Arm training video.